Hi everyone, so today I'm going to be going over linear inequalities in word problems, section 10.3, and I want to make sure that we understand just how to turn words into inequalities. So we've done so far less than. We know that would give me the less than symbol, or the greater than would give me the greater than symbol. We also have talked about the fact that if it says equal to, we have to use a slightly different symbol, so less than or equal to, or greater than or equal to. But when we're talking about word problems, we're not often using the words less than and greater than. So we got to interpret some more words for ourselves. So at most, that means it can be no more than. You might see minimum is less than or equal to, and at least means I need to be at least at this number or bigger than it, which would be greater than or equal to. So interpreting those words is important. So let's try that. Let's translate these, okay? 12 more than twice a number is greater than 5. Okay, so first we set our variable. We're going to let n equal the number. So we want 12 more than. 12 more than, so 12 plus, twice a number means multiply by 2, is greater than 5. Okay? A number x, so they said the variable for me, so in this case I don't need the let statement. A number x is greater than or equal to 8. So number x is greater than or equal to 8. Okay? Okay, so let's try that. So 12 more than twice a number is greater than 5. First, we need our variable, okay? So I'm going to let n equal the number. So 12 more than, so 12 plus, because more than means add, twice a number means multiply something by 2, so multiply that number by 2, is greater than 5. And there I've written an inequality. In a baseball game, a 10-year-old pitcher will throw at most 50 pitches. Okay, so we're going to let P equal the 10-year-old pitcher. Pitchers, pitches. So I probably would have just called it number of pitches. So P will at most, so less than or equal to 50 pitches. Don't want them to throw their arm out at age 10. A small box of cookies weighs at most 15 ounces. So I'm going to let W equal the weight. So then the weight needs to be less than or equal to 15 because it says at most, and at most means less than. All right, this one's a little bit harder. The sum of two consecutive integers. Okay, so an integer is a positive or negative whole number, and if they're two consecutive integers, that means they are right next to each other, like 1, 2 are consecutive integers, 5 and 6 are consecutive integers. So we like to use the variable n for it to be the smallest integer that we're talking about. So the next integer, okay, we need to make sure we understand this part. We did this last year. The next integer consecutively would be n plus 1. Think about 1 and 2. They are 1 away from each other. 5 and 6, 3 and 4. They're all 1 more than the previous one. All right, so it says the sum, so n plus n plus 1 is at least, so greater than or equal to 15. All right, that's the basics. That's basically taking some words and putting them into action, putting them into inequalities. They do get harder. So let's look at an example and some word problem reminders. Okay, so first you always want to write a let statement because that is really the most important part of this. Now, for the first example, I want you to always ask yourself, is it of the form y equals mx plus b, or just mx plus b, or b plus mx? Now, these are the exact same equations. They're just written differently. They're flipped around using the commutative property. But it's important to remember that the slope, the m, is the rate of change. I call it the changing value. Rate of change, I call it the changing value in word problems. And the b is the starting value or the initial value. So you could write it as in mx plus b form, or you could also write it in b plus mx form. So let's see what I mean. A plumber charges $10 per hour and he charges $25 just to show up. Okay, so I know that my starting value is 25. That's how much he charges the initially just to come to the house. I'm doing this one, okay? 25 plus, the changing value is 10. How do I know that? Because it says per hour. So every hour it's going to change by $10. So that would be 10 would be my slope or my rate of change, 10x, okay? So 25 plus 10x. All right, let's try one that might be an inequality. Okay, and remember that a solution to an inequality is different than a solution to an equation because it gives me lots of values instead of just one value. All right, so best balance in her checking account is $75. She must deposit enough money in her account to be able to pay the telephone bill, which is $110. Okay, so we need to know that she has to make at least $110. All right, so we start with our let statement. We are going to let D equal the amount of the deposit, okay? So again, if it's in the form mx plus b or b plus mx, either one, they're the same thing, I want to find that initial value, that starting value. So it looks like the starting value of her checking account was $75, okay? All right. The changing value is how much she adds to the account because we're not really sure how much she's going to add. So plus D. We need that to be at least, so greater than or equal to $110. And there we've turned what could have been an equation into an inequality. Because as long as she makes $110, she's good, but she could make more than that, okay? And still be able to pay her telephone bill. But if she makes less than that, she wouldn't have enough to pay her telephone bill. Okay? All right, hopefully that was a helpful video. Have a great day.